Today we are going to learn about the static, non-static and the local zones. Hello everyone, this is Meedhansh and welcome back to the Java series. So without any delays, let's get started. Alright, so here we are on the screen and now we are going to learn about the three different types of zones, which are the static, non-static and the local. They are also known as the types of variables, but if we exclude the local, then the static and non-static methods are also available. For example, if we are making a main method, so this is the definition or the prototype. It is public static void main. So static here is the keyword which can be used with the methods as well. And firstly, we have the local. These are based on their scope. So scope is basically that how much lifespan do they have. So the first one, that is local, has the least lifespan, which is like local variables. Here I am talking about the local, non-static and the static variables. So the local variables are those variables which are defined within the methods. Methods, like there can be any of these, like for example we are doing some computation and we require a temporary variable, so we can just simply define it inside a method and it is known as the local variable. And the time span of this method, we will know that after how much time does it get destroyed automatically. Then we have the non-static. We will also know about the advantages and disadvantages of the static, because static has a disadvantage, whereas both of these are very useful instead. So non-static are those which, like as the name suggests, it means that they are not static. So they are defined within the class as the separate members of the class, and they are non-static. So we have different names for these variables as well. For example, for local, we have two different names. Since they are defined within the method, so we also call them the method variables or function variables. Okay. And for the non-static, we have two names for this as well, which are the instance or the object variables. And then we have our third type, which is the static variables. Those are also defined within the class. Like static and non-static are in the competition with each other, whereas the local is the one which is defined inside the methods. And it also has two different names. So each of them have two different names as the synonyms. So in case of static, we also call it as the global or the class variables. I'll tell you why they are known as the class variables. And it is also suggested that we should not work in the static zone. And I will also tell you why it is important that we have to leave the static zone and instead we should work in the non-static zone. Because these both are the zones as well. Why do we call these zones? Because like methods can also be defined either non-static or static. By default, they are non-static, and if we want to define them static, then we can by using the static keyword. So it is said that we should leave the static zone as fast as possible because non-static is much more powerful than static. And we will demonstrate that how is non-static powerful than the static zone. We are going to create a simple file for this, and we will call it as the, let's say, class, because we are going to use the demonstrate.java for the demonstration. So we are going to create a different class and we are not going to give it the public. It will not be the public specifier, but it will be the default, which is the package private. So it is simply the class, and let us call it as the static non-static demo, because we are trying to demonstrate that how are these different. And now in this class, we are going to take two different variables. One of them will be int x, and the second one I will take is the static int y. Let us just save this, and it is our static, non-static demo.java, and boom, it's saved. Alright, so we have two members over here. First one is our int x, which is by default the package private or package protected. And then we have this one, it is also the package private because we did not specify any access specifier over here. But we have given the static keyword. And by default, this one variable is the non-static. So we have two members for the class static, non-static demo. And now let us create a constructor. So it is the public static non-static demo. And before that, we will also know that what is constructor. So basically, as the name suggests, that constructor is a method which basically constructs the things which are necessary in the beginning, or the like when we are just starting to run the program. At that time, constructor helps us to like assign values to some variables, or construct some things around. So this is why the constructor is used. And we have some properties for the constructor as well. Like as you can see that I have given it this name, and we have the brackets as well. So let me just write them. So we have the constructors which we are going to use here, and constructors has some properties. Firstly, like they are basically the usual methods, but they have something different. Like there are 3 to 4 points which are different between a normal method and a constructor, although it is also a method. So it has no return type basically. First off, return type like not even void. Usually we call it as like there is no return type, it means it is void. But in the case of constructors, we do not define any specific return type, because void is also a return type. So it has no return type, not even void. Then the second thing is that it has the same name as the class name. Now, when we defined a constructor for a class, what we named it as public static non-static demo. So as of the class name. And we have two different types of constructors. One is the default and the other one is the parameterized. So in our program, we are going to take a parameterized constructor. So two different types. Default is that constructor in which we are not passing any arguments from the, like when we are creating the object, we are passing no argument. And over here, we will not receive anything as the parameter. So it is the default, or the second one is parameterized. So these are the two different types of the constructors. And the most important property, and constructors are the reasons why the on the fly objects are used. You will know why for the fourth point. Now the fourth point is that they automatically get called. We do not call them by, like, let's say with the help of reference variable, they automatically get called. But when this is the most important property of the constructors. That is why on the fly objects are used very much, because when we are creating an on the fly object, basically it's an object, and when an object is created, the constructor gets called automatically. These are the main four properties of the constructor. There are some different as well, but these are the ones which we need to keep in mind for now. So they automatically get called, and thus they are known as the constructors. Because once the object is coming into existence, at that time we need something necessary to happen. We need some assignments, we need some construction. Like if we are doing the Java swing, or we are working with the Java FX, so in that case, like when we try to create a window or a desktop application, constructors are required, because with the help of constructors only we can create the frames, and thus we can design our desktop application. So constructors are required in almost every type of program, and thus constructors are also used to get out of the static zone, because we have the main method as our static zone. So we need to get out of it, so we can simply create an on the fly object of that class, and thus we are out of the zone. That is why we are also creating two files, like demonstrate and then the static non-static. So we will be inside the non-static zone after we create an object for our this class. So these are the major properties of the constructors. And let's get back to our code. So we have the constructor, and as I mentioned, we will take a parameterized constructor, and we will take two different variables, int p and let's suppose int q. Now we have to define the data type for all the parameters which we are taking. Let's say if I take another one, let's say it is string, so string name or anything. So we must define that whether it is a string, it is an int, boolean or anything else, because it is a single line. So with the help of comma we separate the variables. So we must define the data type again. In this case, if I am taking int x, int z, so there's not a problem because we are simply taking the variables. But in this case, I might require strings, I might require the integers together. So that is why we have to define the data types for each and every variable in a parameterized constructor. So we have two variables or two parameters. And now, as I mentioned about the local variables, so these are the local variables, because as I told that the constructors are methods, and those are also known as the method variables because they are inside a method. This portion is also known as being inside the method, this one inside the brackets, and this portion, let's say if I have another variable over here, int let's say pqr, so we have the int r. So this is also a local variable. Now what we will do is, like, we need to do some necessary assignments. So we will do that, we will assign value to the x and the y. So x is equal to p, whatever value we get in the p, let's say we get 10 and 20. So 10 is stored in x and 20 will be stored in y. So y is equal to q. And as I told in the class for operators that the assignment goes from right to left. So from the right, the q value for the q will be picked up and it will be assigned to the y, which we have already given as the static one, and this is the non-static. Those are the local. So those are three different types of the variables which we have already covered, but we will see that how they work. Now we will create a simple method. Let's suppose public void show. It is a non-static method. So in this method, we are going to simply print like system.out.println. Simple. There's nothing too complicated in these. We have a simple show method. Once we will call it, it will show the value for x and y. So let us demonstrate it once. So we will create an object for the static, non-static demo s1, let's say, is equal to new static non-static demo. Now let's say we pass two values. So those are the arguments which we are passing to the constructor. Now once this particular object is being created, those values will go to the constructor right away. They will be stored here and then they will be assigned to x and y. That's it. This is the main work of the constructor. So let us write the properties all together for the three different types of the variables. So we will just remove all this, and for the locals first. So locals, as we already know, those are the variables which are defined within a particular method. So their lifespan or their time span when they are alive, let us just write that their lifespan is from when the method starts working, and then once its work is done, they are also destroyed. So like for the constructor also, so they are being destroyed once the constructor is finishing its work. So they are being destroyed. By whom? It's none other than our GC. Because of these GC, we do not require to create the destructors as well. Otherwise, in the traditional languages, we must create the destructors for like cleaning up all those variables which are not required now in the memory. So that's why GC is our friend, the programmer's friend. So they get destroyed once the method stops working. Like constructor gets called, those both the variables come into existence, and then they assign the value to y and x, and then done. They are destroyed. Now let us create a memory map for this. So according to our program, we are creating a basic object, and let us just call the method as well, dot show. Let's see what happens. We'll go to the command prompt. We will compile both the files, java c static non-static demo.java, and then java c demonstrate.java and java demonstrate. So we got the simple values 10 and 20. And let's see what was happening. Like the diagrams we created in the classes, objects and references, same thing we will do here so that for the better understanding. So according to the code, firstly, an object is being created. So let's say this is our object, and inside this object there is a variable. There's just one variable inside this object, which is x. It is being created, but where's y? The y, like I told about the static variables, they are also known as the global variables. So they do not take up space in every single object. They take up space just differently in the memory. So like they are not repeated, they just take the space once, and once the program is executed, they occupy the space in the memory, whereas those non-static ones have a little less scope, because the moment this object gets destroyed, they also get destroyed. But this one is alive until the program is running. So we have the y over here, we have created an x and an object. Let's say this object has the address 2000, something different, not 1000 this time. And we have another variable. Guess which one? It is the s1, because we require to store this address somewhere. So it is s1, and this value is being copied to the s1, which is 2000. And now this particular reference variable is referring to this object. So they both are connected now. So till now, this statement has executed, an object is being created, and moving to the constructor. So once the object is created, the int x occupies its space inside the object. So it is linked to one particular object, and this one, static int y, takes the space differently in the memory. Now the constructor gets called because we created the object. So new keyword triggers the constructor. So now constructor gets called, the value 10 is stored in P and 20 in Q. Now x is equal to P, so 10 is copied to x, 20, which is Q, is copied to the y. Moving back here. So 10 is copied to the x and 20 to the y. Simple. And now we go back. Once the constructor has completed its work, so like there were two variables that came into existence. So those were the P and the Q. So this is the P variable and this one is the Q. P had the value 10 and this one had the 20, which we got as the argument from the object when the object was being created. And the P gets copied to 10. The Q gets copied to the Y. So this is all the copying with the dotted lines. So all these gets copied, and once the curly brace which ends the constructor, this one, this is the last place till when the P and Q are alive and they are now destroyed. So once the curly brace comes up and they get destroyed, So let us just remove them by P and Q and done. So once they have copied everything, and now we have the values in the X and Y. Now what we did next was that we called that method, which is the show, which is a non-static method. So back to the demonstrate, and we have s1.show. We are calling this method using the reference variable. So s1.show. You might be thinking that why I am just telling you the little things that it is being called by the reference variable. That is because there is a little differentiation which I will be telling you further. So s1.show, and the show method gets called. So the value for x and y gets printed, and we get the output 10 and 20. Simple till now. Now, what if like we should create another one? Before that, we will create a static zone now inside the static non-static demo file. So it's a method which is public static void, not main. Don't be in the flow and saying the public static void main. We will keep the name as display. So similar to show, we will just copy from this and paste it. Done. Copy pasting saves a lot of time, but be sure like you are not copy pasting something wrong. So now our class is fully ready because we have a static variable, we have a static zone, non-static zone, local variables, and the non-static. There's a mixture of everything. So this class contains all types of variables and the zones. So now moving back to the demonstrate. Now what we will do is that we will call the s1.display. What should come as the result? We expect that it should be the, like, we got the 10 and 20 for the s1.show. So s1.show gives us the value as we already have seen this. So it gives us 10 and then 20, which is the println. So it comes in the next line. Now, what we expect from display is that it should also give us the same output. Display, and the value, the expected value should be 10 and 20. Why expected? Because we haven't tried running it yet. But we will not get the output properly. The reason is that, like, first let us just execute it. So we will first, we have made a change to all of these, so we will just compile. Okay, so like I didn't even compile the demonstrate yet, and I just compiled the Java static non-static dot demo dot Java, and I got an error which is non-static variable x. X was our non-static, we did not define it anything, so it is the non-static variable, cannot be referenced from a static context. Now static context, which is the line 20, let us check what is on the line 20. So this is the line 20 and it is inside the static zone. So now this is the disadvantage of the static zone. Why we should not use the static zone? So the reason is that the static cannot access the non-static members, whereas it can access the static ones. So that is why we cannot get the output. So once, let's say I comment it and retry running it, then demonstrate, compile, run. We got the output 10, 20 and 20. So now this statement was error causing, so I just commented it. Now why is it creating the error and why we cannot access the non-static members from the static zone? The reason is that the static zone, like we cannot access the non-static one because the static is the global zone and the static can only access the static members, but it cannot access the non-static members. Why? Because now let us see one property of static. which will help us understand it more clearly. So, so what we are saying that the static members can be directly called with the class name. Why? Because they are global. They are not connected to any object. In this case, X is connected to a particular object. If another object is being created, like we have another object over here, so it will have its own X inside it. Like it has its own X inside and it will have its own value, but the Y will remain same. And it will also have another reference variable, and let us just code this also. So it will be s2, and let's say it has the address 2100. So we keep the address 2100, and now this one is referring to the object. So now let us see, like we should just code it as well. Non-static demo s2 as mentioned in the memory graph. So static, non-static, it's a huge name. And now we assign the values 30 and 40. Let us just comment this once. Now I try the s2.show. Okay. So what do we expect from both these? The s1.show should give us the output 10 and 20. The s2.show should give us the output 30 and 40. Because in the case of s2 we passed 30 and 40. Simple. Let us try executing it. Let us just clear the screen and we recompile it. There's no problem. And yes, we are getting the exact output 10, 20, 30, 40. The one we expected. Now, if I write s1.show again, what will happen? You might be thinking that again this thing will happen, that it will give the output 10 and 20. So the expected output should be 10, 20, 30, 40, and then again 10, 20. So let us see if we are getting this expected output according to our statements. Look, 10, 20, 30, 40 till this, even 10 again, it's fine. But how we are getting the 40 over here? The reason is that, let us just see the map again. We will remove all this and just remember this property of static, that we can call it with the class name. So what is happening now is that another P and Q is being created. It is copying the value to X and Y. So we got the value now in this object 30, and this value in Y is being overwritten. Now the 20 is 40. Earlier when it was 20, till this statement, like before this statement, the value of X and Y was 10 and 20. But after this statement executed, the value changed to 30 and 40, and it showed. Now, once I am trying to do this s1.show, what is happening is that the s1 object has the same value for X. It is the 10 only, it is the retained value. But when I am trying to access the Y, since it is the static or the global one and it is having a different space from the objects, it is somewhere aside in the memory, so it was overwritten by the second object, and thus it gives us the output 10 and 40 because it was overwritten. We do not have the 20 value anymore. So this is the reason why we got 40, like 10, 20, 30, 40, and then again 10, 40, not 20. So this is how the static variables work. They are global for each and every object. All these objects access just one Y. If we want to access with this one, we can access it. If we want to access with this object, basically not object, the reference variable, So we can access the y, but it is having the different space or different allocation, like not inside an object, but outside the object, as it is a static variable or a static member. So moving back. Now, as we discussed about the property for the static ones, and we will know about the the con of the static zone. As we got the error that the non-static variable x cannot be referenced from the context, from the static context. So till now we have understood that how do static variables work, how are they global. So they are global in this manner that they are just globally one. Like if we take an example of, let's say, the PM. So like the PM of India is just one. For every country, the PM of India is just one. But if we talk about the Chief Minister, so if I ask you who is the Chief Minister, firstly you will ask me that which state, like is it Punjab, is it Haryana, which state? So although India is just one and thus we have a single entity as the Prime Minister, but in case of the Chief Minister, if we take the states as the object, so each object has its own Chief Minister. So first of all, we must know that which object or which state. So we are going to implement this now and check the ambiguity. So let us just remove this statement, and we are going to use that property. Since display is a static member or a static method, so we can directly call it with the name of the class. The class is static non-static demo.display. Now, if I try to do this and if I just uncomment this, so and let's say we have the S2 as well in the scene to get more clarity. So S2 we have the value 30 and 40. And now at the end I am trying to display the value. So since we saw that the global variables are there, so we should get the value 10 and 40 again. But now let's see the value first, what we get from the Java. So we will just recompile the demonstrate. We got the same error again. If we try to compile this one also, we get the same error that the non-static variable x cannot be referenced from a static context. Now it will be pretty much clear that when we are trying to access the x from the display and it is static, since we can access it using the name of the class. So when we are using the name of the class, we do not specify the x because x was non-static and thus it was taking space for each and every single object. But now if I am just simply writing that, so in this case, how will Java know that whether I have to show the x for the first object, for the S1 reference variable or the S2? Like it will be confused which x. So that is why, to avoid the ambiguity, we cannot access the non-static members from the static zone, because the non-static are like for each and every object they are different, but the static ones are the global. So we can access the global object, global variables using the static methods, but not the non-static members. So this is the reason, like when we are writing the s1 dot show, in that case, first off, show is a non-static, ns short form. So since it is non-static, it can access the y and the x. But in the case of this, we cannot access the x. We can access the y although. So this is the same thing again from the who is the Prime Minister and the Chief Minister. So you can tell the Prime Minister of India, but if I ask you who is the Chief Minister, you cannot tell me. You will first ask which one. So now in this case, Java is asking that which x, this one object or the other one. It cannot find the x. So that is why we cannot access the non-static members from the static zone. And this is the reason why static zone is avoided by us, and instead we should just work in the non-static zone. Rarely, in some cases, we require the static zone. Like first case is obviously the main method. Since let us see that how we have the main method static. So when we are writing the Java C, let's say we have a simple file hello.java which has a hello world program, and once this statement is executed we have a class file in the folder. So let's say this is our directory or the package. So this is the package and its name is, let's say, the same name, Java YT, which we are using. So now in this Java YT package, a new class, a new file with this file will be created. Like we have the hello.java already, and we have another file now after this statement gets executed, which is hello.class. This class file is the bytecode for this hello.java. We will just see that how does a bytecode look like. So if we just go to the folder, go to our folder, which is the Java YT. Where is it? Here it is. And look, we have three different class files. The one is we have the demonstrate.java, and for corresponding one, this is the demonstrate.class. For static non-static demo, we have the static non-static demo.class. Now, when we are executing this statement, Java hello, since we are not writing dot class or dot java, we are just simply writing the hello. So when we are writing hello, how will it know that which method to call first? Although Java knows that we have to call the main method. So this whole statement, or simply if we are running this, so this will be converted into hello dot main. The main method gets called. And since main method is the static method, like public static void main, so we can directly call it with the name of the class. So if we are trying to execute the demonstrate file, then the statement will be demonstrate. So this statement gets executed and our main method inside the demonstrate class gets called, because it's a static method, so we can call it directly with the name of the class. And since now we know that we cannot access the non-static members from the static zone, that is why it is less powerful. So I have a small chart. Basically, it's telling about the accessibility. So can static access the static members? Can static access the non-static? Can non-static access the static? And can non-static access the non-static? When we tried to access the static to static, like the display method was static and our y, which was the static int y, so it was also static member. So both of them were static. So yes, we can access both of them from like one and the. So the display can access the static member, which is the y. The reason is that the non-static ones are different for each and every object, but the static ones are the global. And since they are global, so they are one, and thus they can be accessed by the static zone. Then we have the next one. Can static access the non-static? We saw the demonstration, like we tried to access the x variable from the display method. So no, we cannot access it. The reason that non-static are different for each and every object, and thus they cannot be accessed. Now, can non-static zone access the static? Like in our case, we have the non-static zone as show. So can show access y? Yes, it can access y because it is global. So non-static has no problem with accessing the global member. because it's like one for the whole class. Can non-static access non-static? Yes, it can, because the non-static methods can only be called with the help of the reference variable. We cannot call them directly with the name of the class. And thus, if we have the reference variable, it will surely be connected to some other object, and that particular object has its own non-static member or the variable, and thus the non-static can access the non-static member. So yes, now see, this is the static zone accessibility and this is the non-static zone accessibility. Which one is more powerful? The non-static zone. It is having the 100% access to both types of members, whereas the static zone has just the 50% access, just static to static, but we cannot access the from the static to non-static. So that is why the non-static is recommended whenever we are trying to code. And if we are just working with the static zones, then it might be the sign of the bad programming, and that is why we are going up with the non-static zone. Because static zone can somewhat be much more comfortable, like we do not need to create a reference variable, we can just simply call it with the name of the class, but it creates the ambiguity when it comes to the accessibility with the non-static members. So that is why it is recommended to use the non-static zones only. Now we learned about the three different names of all the three variables, right? We have the local, non-static, and the static variables. Here I am talking about the variable, not the zone. So the locals are also known as the method and function variables, or they are known as one per method or one per function. Non-static are known as one per instance or one per object. The statics are known as one per class. Now, why are they named like this? In this context, we are talking that this is just one over here. We do not have multiple of them. In case of the non-static, which is the X, so X we have multiple. They are one per object or one per instance. So they are different for each and every object. But in the case of static, they are just one per the whole class. And the whole class members can access this since it is the global. Whereas the locals are those which are one per method. They are inside the method, so they have very less accessibility. And even we cannot use the access specifiers for the local variables. They can only be used for the non-static and the static members, because access specifiers define that from where can they be accessed. Are they public? Are they private? But since we cannot access the members inside the method because they are created when the method starts to work and they get destroyed when the method has completed its work. So we cannot access the local members because of this particular circumstance. So let us just summarize what we did learn today. So we learned about the static, non-static and the local variables, and we learned about two different zones, the static and the non-static zone. And we learned about the advantages and disadvantages of both of them. So the non-static has the advantages from all the sides, but the static has just 50% accessibility compared to the non-static zone. And that is why we must work in the non-static zone instead of the static zone. We learned about the constructors, how do constructors work, their properties, and how do we define them. And we learned about the accessibility, that can static access to static, can static access to the non-static, and so on. Like we have four different types of accessibilities. And lastly, we learned the names of all of them. Like local is also known as the method or function variable, and it is one per method. Non-statics are one per instance, also known as the instance or object variables. And the static variables are also known as the global or class variables, or the one per class. So that is it for today. I hope you liked the video, and if you have any queries related to the static, non-static and the local variables or the static, non-static zones, you can comment down below. So Thank you very much for watching, and I will see you in the next one.